So electronegativity. Electronegativity is the capacity of an atom to attract the shared pair of electrons towards itself in a covalent compound. Actually, the electronegativity was explained by various scientists in different forms. Pauling, a scientist, and his idea was electronegativity is the power of an atom in a molecule to attract electrons to itself. Actually, he compared the bond dissociation energies of various molecules. Look here, you are taking a molecule AA and you are taking a molecule BB. This AA, he calculates what is the amount of energy to be spent to dissociate this bond, to break this bond. And what is the energy to be spent to break this bond? And then he calculated if A and B are combined, what is the energy to be spent to break this bond? By observation, he found that the bond dissociation energy of AB is greater than the dissociation energies of AA and BB. So he wanted to find out the difference between the bond dissociation energy of AB and the average bond dissociation energy, that is arithmetic average bond dissociation energy of AA and BB. And he proposed an empirical equation, delta, that is the difference in the bond dissociation energies, is equal to the bond dissociation energy of AB minus half into, that is the average bond dissociation energies of AA plus BB and which is equal to 23 into the difference of electronegativities square. So this was the empirical formula proposed by Pauling, and which was simplified by him, and he found that 0.208 square root of delta is equal to chi A minus chi B. But actually, because of some discrepancies in the experimental observations, he changed the arithmetic mean into geometric mean. So in the case of geometric mean, he has put EAB, that is the dissociation energy of AB minus dissociation energy of AA into dissociation energy of BB whole power half. He took the square root of this, which is the geometric mean, and he called it delta dash. So delta dash is equal to 30 into chi A minus chi B, which are the electronegativities of A and B's whole square. So he proposed another empirical formula. It is 0.182 square root of delta dash is equal to chi A minus chi B. So the dissociation energies in the case of a Pauling's calculation has to be taken in calories per mole. You should not substitute here in the units joules per mole. You have to substitute the bond dissociation energies in the unit calories per mole. But in this case, AB is found to be more stable than AA or BB. The reason is, it is because of the polarity that is induced in the molecule. So if you take A and A, practically there is no difference between the electronegativities of these two atoms, because the shared pair of electrons are common for A and it is common for this A also. Hence the shared pair of electrons are found at the middle. The force with which the A is attracting the electron, the force with which this A is attracting the electron, they are equal, and hence the electron density is neither shifted towards any direction. Similarly for B. But in the case of AB, there is a small difference in the electronegativities. Therefore, electrons are shifted. Suppose if B is found to be more electronegative than A, the electron density is shifted towards B. Hence, B becomes delta negative and A becomes delta positive. Similarly, if A is more electronegative, A will become delta negative and B will become delta positive. So apart from the sharing of electrons, a little Coulombic force of attraction, which is the polar attraction, is also there. That polarity is actually increasing the bond strength. That is why the bond dissociation energy of AB is more than that of AA and BB because of the polarity. So this was the explanation given by the Pauling. So the next explanation was, see in the previous case, I have to share one more thing. The hydrogen is given an arbitrary value of electronegativity 2.1. The highest electronegativity is of a fluorine 4.0. So it is arbitrarily fixed for hydrogen. The value is 2.1. See, another scientist who gave the idea, Allred and Rochow's approach, they said it is the electrostatic force of attraction exerted by the nucleus of an atom on the valence electron. So the valence electron is attracted by the nucleus. If the nuclear power on the valence shell is more, then it will attract even the shared pair of electrons. So this is what is the approach of Allred and Rachow. They said it is the electrostatic force of attraction exerted by the nucleus of an atom on the valency electron. And they related the electronegativity with the effective nuclear charge. Is it effective? Is the effective nuclear charge, which is actually determined using the Slater's rule. Later on, I will teach you what is this Slater's rule. And he came out with an empirical equation. The chi, the electronegativity, is equal to 0.359. Is it effective? Effective nuclear charge divided by R square plus a 0.744. Here the R is called is the covalent radius expressed in Armstrong units. This is Allred Rochow's approach. And the next approach is Mulliken's approach. What Mulliken said, it is the average of the first ionization energy and the electron affinity. See, ionization energy is the tendency of an atom to release an electron. Electron affinity is the tendency of an atom to attract an electron. If you take the average of these two forces, that will tell you the capacity of an atom to attract the shared pair of electrons. That was the approach of Mulliken. So Mulliken said it is the average of the first ionization energy and the electron affinity of an atom. And it should be the measure of the electronegativity of the atom. And he gave this equation. It is chi, the electronegativity is equal to 0.374 IE plus EA, that is ionization energy, and electron affinity by 2, that is the average, plus 0.17. So it is further simplified as 0.187 into ionization energy plus electron affinity plus 0.17. So this is the equation given by the Mulliken. So with this we come to the end of this class, and tomorrow I will discuss what are all the factors affecting the electronegativity and what are all the applications of electronegativity. So these are all the things we are going to discuss tomorrow. Do you have any doubt?